Hello and welcome to another very beginner-friendly Solana tutorial. Today we're gonna have a look at things that I usually do that might be confusing for beginner devs, because if you haven't been around for the past 2 years where I did the fundamentals course, you probably miss some basics, and because I constantly work with them, I don't even mention that stuff anymore. So for me it's all natural, but for someone who's new or who might just be new to my videos, some of that stuff could be confusing. And recently I got a few mentions saying that what I'm doing is great, but a bit too complex or a bit too much over the top of their head or whatever. Got a few of those comments, so I want to get people up to speed on the things that I'm doing, specifically looking at account data and hex dumps, because that's just something I keep doing in almost every video. So I want to have you understand what I'm doing there. If you've been around, you can skip that video. This is really intended for newer people. So hello, I'm Andy. I do videos around here about Solana development, and today I'm gonna drag you in my world, or something like that. Let's do some Solana development. Very basic, but I'm gonna explain it in detail what I'm doing. Okay? Let's go. I have a transparent neck. Should I take it off? I might get cold if I take it off. This is not the best hoodie for working with green screens. Nah, it's fine. Whatever. We'll deal with it. That's just part of the game. Okay, what we're going to do today is write an anchor program. And I'm not gonna start in the very beginning with installing everything. I'm assuming you will figure that out. I'm also not gonna start with zero, you have no coding experience or no Solana experience. So I do assume that you're familiar with Solana development, just not the way how I do things. So I'm going to show you my way of doing things. One way of doing things is I make a new project for everything, make a new folder for every project. Let's do, what do we do today? Data demo. I'm not too fussed in giving good names, another thing that I do. Anyway, so anchor init, and then I will open this. And also one way of doing things for me is having the project stuff on the right. Usually people have it on the left, so if that confuses you, I'm sorry about that. It's just nicer because I'm here on that side of the screen. It's just how I do things, okay? There's reasons, but that's just how I do things. So anchor init gets me an anchor project. I need to give it a name, beginner demo. There we go. Then we get the project stuff here on the right, because that's how I like to do things. And the real program is here in this librs. We're not gonna do much with this. And such that I can showcase some things, I'm just gonna write a super simple program. But also, because it annoys me already, another way of how I do things is grind my own key pairs, just so I have a nicer program ID. And I usually do that by making a folder keys, going to that folder and then saying Solana keygen grind and starts with, and then I don't know, demo or whatever, so that my demo program, the program ID starts with demo. There you go, demo dp. So then I can copy that in here, and then also copy that into my anchor project, target deploy, and then the key pair, because that, if we do anchor deploy, that's the key pair that it takes for the program ID. So I have to copy it there that it's actually gonna deploy to this address. Okay, we will also get the SO file here, so that's the actual program then once we build. We can do that. Actually, let's go to our project and say anchor build. Looks like I have a chain now. Yeah, bling bling. Fun. So once we build our anchor program, in the beginning it just once needs to build all the dependencies as well. That's why it takes longer. There we go. Now we're building our thing. And once we build it, we get our SO file. That is the actual program that we then deploy on chain. So that's the executable file. What it's doing now is creating the IDL as well. You might already know all of this, but I'm saying this stuff to get as many new people up to speed as possible. The IDL, by the way, is a JSON representation of our program where it tells us what is the program ID, and it tells us all the instructions and accounts we will have and errors and everything. So it basically neatly defines an interface to our program. IDL, does it stand for Interface Description Language? What does IDL stand for actually? I forgot. Interface Description Language. Yeah, I still know. An easy to use program interface. Yeah, not gonna go into details, but yeah, that's that. We will use that, but first we will write the actual program. So in Anchor, you basically define the instructions as functions here, and we will just have one instruction that initializes a data account. Because what I want to do today is work with accounts, work with a data account. So what I'm going to do is I'm going to define myself an account. So this is a struct data account. My data account will have the following data. First, you will get number, like a U64. Wait, we're in Rust. Then you will get an address. And you know, in a real account, you would name that properly, but this is just demo data. The data account will just hold some data. So an address is a pubkey. Anchor still works with pubkeys. They might upgrade to address eventually. I would assume that they do that in version 1, but currently Anchor is in version 0.32. Yeah, we're in 0.32. Version 1 will change stuff. For now, it's still called a pubkey here, so it's a pubkey. That's a whole other, I have a video on that conversation. It's an address with a type pubkey. Okay, what else might I want to store in a data account? Maybe something with variable length, like an array. An array of what? I don't know, just some bytes. And then maybe a better demo would be text. That's also variable length if we work with a string. So those are 4 types of data that we could have in our account. And all we're gonna do is initialize an account that holds some data. How about that? So in our initialize, we will need to have a signer that pays for that account if we create it. I'll call it payer, which will be an account that we write to because we pay from it. MUT means mutable, so we request that we have that as writable, that account. Then we will request another one as writable, the data account, which will now be an account of type data account. So we want it to have this very format, this very structure. Oh, I guess I need to give you that now. And then we can tell Anchor directly that it should initialize that. And we provide the payer and we provide the space. Oh, and now, oh, it doesn't like that. Yeah, if it's an array, if I would want to do an array, I would need to give it fixed length. For instance, 8 bytes, that would work. Then it's really an array, but it's a fixed size array and not a variable length array. Which, fair enough, let's do it fixed size and then have one variable length string here. So, space. And this is already one of the things that you might really struggle with if you try to follow along when I'm making videos, because I just keep doing those things automatically and I don't really talk about it. And what I am doing here is converting a data type to the size that it needs in bytes. Let me explain. This number, for instance, has type U64. That type is an unsigned integer with 64 bits, which means in bytes, that's 8 bytes, because 8 bytes make 64 bits. 8 times 8. 64. Welcome to computer science. Those numbers, they're just engraved in my head, are just powers of 2. So to store this number, we will need 8 bytes. So the space will be 8 for just this number. However, there's more. There's an address, which is a pubkey, and a pubkey always has, guess what? 32 bytes. 32 times 8 bits. It's 32 U8s. A U8 is 8 bits, is 1 byte. So that would be plus 32 for just those two. Then we have another 8 times 1 byte, which is 8. And now it gets complicated. We have a text. And we don't know how big the string is. So what we can do is say the maximum length that we allow for the string is, I don't know, random number. Let's say we allow 20 characters at most. Then we can take plus 20 to be able to store that string. Correct? Not quite, because the way a string is serialized with Anchor is it takes 4 bytes to indicate the length. There's no null determination here. If you're coming from C, that's not how we do things. We define the length up front using 4 bytes. So we would need another 4 bytes here. So 4 plus 20, might as well take the max length here instead of the 20. So the 4 is for the length of the text string, and then this. So that total here is what we need to store those 4 things. However, and that's another caveat that might come out of nowhere if you're starting Anchor development, because what every data account also stores that it doesn't show here is a discriminator for the account. So the first 8 bytes in the account actually will be used for identifying which type of account it is. That's just something that Anchor does. So what we need to do is add another 8 bytes in the very beginning for the discriminator. So we have discriminator, the number, the address, the array, and the string, making up the total space of this account, that number, which is whatever you calculate that. So that's that. Now, this thing is complaining that we need the system program such that we can do the init. Fair enough. We give you the system program as a program account, same lifetime, and I tell you to use the system program. That's how it's done in Anchor. And then that doesn't complain. Now, you want a U size and you found a U8. Okay, fine. I can also just type this to use, make my life easier. Fine. Okay, now we have the accounts for this instruction defined. Let's actually implement what the instruction is doing. And all I want the instruction to do is write some data to that data account. So if I don't want to write random things in here, I could get them from instruction data. I call it an input number, a U64. And the text, I'll also put in some input text, a string. There you go. Write in accounts, data, address. So to write in Anchor, it's pretty simple. I just get the account, so the data account here, and say what part I want to write. For instance, the number. I say write the input number onto the number field of this data account. Simple. The same I'm going to do with the text. Write the input text to the text. And I'm also going to write the address. And what I'm going to write to the address is the address of the payer. Let's say I would store the authority here or whatever that could be. So I'm going to get that from the context accounts payer key. And what else? There's still an array. What am I going to write to the array? To the array, I'm going to write something static such that you can see 1, 2, 3, 4, 5, 6, 7, 8. Random. Mismatch types. I'm having integers. You want U8s. Fine, make it all U8s. Here, type it, 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 type it. Is that better? Yeah, now we just don't make a slice and then we're done. Cool. Easy. Okay, so we write the number, we write the address, write the array, we write the text. That's it. And then we say okay. And Anchor does take care of actually storing that stuff properly onto the account. So let's build and deploy this program. Quick little demo program here. So we do Anchor build again, which this time should be way faster because I'm just building my stuff. There we go. Done. And then I can say Anchor deploy. Although first I need a key pair. Ooh, that's a nice amount of sol that I have here. Do you think that's enough to deploy a program? Probably not. Guess I need another key. Damn it. But you know, I love to grind. So let's get myself a key. It starts with ND. There you go. NDE. Should I explain to you what I'm doing here? I'm setting the key that the Solana CLI takes to this path. This is just a subcommand that gets me that, such that I have the absolute path, such that I can do it from anywhere. That's just something that I got used to doing, so I keep doing it. It would also be fine if I were to use the usual config Solana ID, but I prefer to have one key for every project such that I don't confuse stuff and then confuse mainnet with devnet keys and stuff. It's just, I like to, separate them. But that also means that I need to get an airdrop every time and fund new addresses. Do you think I can get an airdrop? Yes! Awesome! I love it! That doesn't always work. But since we have 2sol now, we can deploy this program. So we just say anchor deploy. And 2sol will be enough to deploy even an anchor program. I'm so looking forward to V1 that should make that more efficient as well. And I don't need 200 transactions to deploy a program. But on devnet it's fine. Oh no, transactions failed. But we did pay for that account. We paid 1.5, 1.4 something sol. Let's try again. And if you now tell me that I don't have enough sol, then I'm gonna... there we go. That worked now. It's also writing the IDL on chain. Did make a video on that a few videos ago. You can check that out if you want to understand what that account is. And also that I was told will change with version 1 of Anchor, because then it will just use the program metadata program and not do it itself anymore. Okay, anyway, so we have a program deployed now. That's the program ID, look here, as we also have here. So that program is now deployed. Now the question is, how can we call it? And the easiest way is to make use of the IDL, because the IDL tells me what instructions it has and what the discriminator of that instruction has to be and what accounts we need to provide and what arguments, aka instruction data, we need to provide. Then it also tells me what type of accounts it has. There's the data account, which will store a number, which is a U64, an address, which is a pubkey, an array, which is a 8 U8s array, and a text, which is a string. And it also tells me the discriminator, which has, guess what? 1, 2, 3, 4, 5, 6, 7, 8 bytes. That's the 8 bytes that we had to put this first 8 for. Those 8 bytes, they are stored on the account to discriminate between different accounts. Same way that those 8 bytes are used to discriminate between different instructions. We only have one instruction, so that's the discriminator for the initialize instruction, which means those will be the first 8 bytes of instruction data to that program call. And that might seem all a bit complicated, so usually I would recommend that you just use Codama or something to automate that. But in this video I'm gonna do both things, doing it the easy way and then doing it my way, or how I often do it, which might be confusing, but then hopefully you get the connection of what I'm doing there. I'm still so annoyed by this. Is so green here. Maybe I need a different hoodie. How about this? I point down there. Point up there. Okay. First, the easy way. If you've never worked with Codama, I also have a video on that. And I'm just gonna borrow the code that does the conversion. So let's make a new directory, client stuff. With client, I usually mean the front end stuff, so not the on-chain stuff, but the stuff that I run on my machine that interacts with a blockchain. That's what I see as the client. So I'll do in the client, or the app, I sometimes call it. Here I'll do a new file with run Codama is usually how I called that. And then we will need a bunch of JavaScript packages. So now we're working with JavaScript, not in Rust anymore. The on-chain program we did Rust with Anchor. And now we're gonna do TypeScript, and we're gonna then use the Solana kit. But first just the Codama stuff. So pnpmi Codama and types node. And while we're at it, for later we will get the Solana kit. There we go. All of that is added. What do we need for the path type? There we go. Okay, we don't need to go through what that does exactly. I'm just gonna tell you on a high level. I'm gonna tell it to go to my beginner demo project and load the Anchor IDL and then create the Codama IDL from that, or create a Codama root and then generate the JavaScript stuff from this Codama IDL or root. The Codama IDL is basically just a different way of representing this, but basically I could show you. I'm gonna log it for you, and then we're gonna just run this. So this is quite ugly now. I'm gonna make a file for it temporarily such that I can format that. Okay, so this is now similar to the Anchor IDL. It was generated from the Anchor IDL, but now it's in Codama format. And Codama does it with those nodes. We have the root node, then we have the program node. The program node has accounts, so account node. And we see pretty much the same things, just differently. There's a discriminator of 8 bytes. That's the value for it. Then there's the number, a U64, the address, which is a pubkey, an array, 8 bytes, and the text, which is a string in UTF-8 encoding. So yeah, and then the instructions. Also here we see the accounts that it needs, whether or not they're assigned and everything. That's all encoded here. It's just a different way of writing stuff, which arguments it takes, the discriminator, 8 bytes, then a number, and then a string. No, wait. Then a number, and then a string. And here it even says more specifically what the prefix of that string is, a U32. So guess what? That's 4 bytes, because 4 times 8 is 32. So we have 4 bytes for the string prefix. Here we already see that as well. So that is just more verbose, but pretty much says the same things. And from this Codama IDL, I can now create TypeScript code, and I already did that here. And with that generated code, it's much easier to actually create those instructions when working with the kit. And I love working with the kit. If you're still working with the Solana Web3.js, you might want to change to the kit. I do have a video on that. Can check it out up there. Check it out. In that video, I talked about the difference between Solana Web3.js to the Solana kit. The kit is newer. I recommend that you start working with this. Personally, now that I got used to it, it's just so much nicer. Well, so much. It is nicer and it's more efficient and it will be supported for longer. The Web3.js might not be supported for long anymore. We don't know. Anyway, so let's do work with the kit. Let's create ourselves a file to call the program. And also here, I usually just copy the same code all the time from a previous project, but it's always the same, right? I basically just import all sorts of stuff from the Solana kit. And what that does, I always have the same template. And what it does, it loads a key pair from a file. So here I will then also give it the correct file. It's gonna be the same one as the key that I used here, because why not? I don't want to create another one. I don't want to grind Andy again. Things just say. Yeah, that's a normal sentence, right? You don't want to grind Andy again. No, you don't. So here you go. Have that key pair. We load that. Then we create an RPC connection. If you're used to Web3.js, that's just new connection. And then we define our instructions, which we then put into the message that we put in that transaction. We add a fee payer, we add the block hash as you need for a transaction. Then we sign the transaction and we simulate it. And if we don't get an error, we actually send it. That's what we do here and lock the signature. So to define the instructions, here I can now use the generated code that we created here in this folder. So I can import, and that would be, wherever you created, from my this beginner demo JavaScript client. Here should be all the stuff like the get initialize instruction. It calls it that because the Codama IDL said that instructions, there is an initialize instruction, and from that name it now has this get initialize instruction. So we can call get initialize instruction, and then we just need to provide the things that the initialize instruction needs, which are the payer. I have that, that's going to be my key pair here. The system program it will get automatically. You know that from that question mark, because that means it's optional. The data account, I should have called it data account and not data. That's a bit confusing. So yeah, let's fix that just so you see that where that is coming from. It's called data because here I called it data, but yeah, the naming here is not ideal. So I'm going to rename that to data account. There you go. Then it's data account. Then I just need to rebuild real quick, which rebuilds the program and the IDL. The program doesn't really change because I just changed the name, but the IDL did change. So if I run the Codama stuff again, then that should update. And now that thing here should be called data account. Magic. Okay, so data account, I'm just gonna create a new account. So I'm gonna do data account be a generate key pair signer, and then I can use this data account here. That should be fine because it needs a transaction signer. Perfect. Yeah, that's a transaction signer. Good. And now we just need to provide the input number. So that's the instruction data that we provide now. That will come in here then. This input number, this is what we're providing here. And that's gonna be whatever. Let's just give me a random number that you want to see on the account. How about we do a huge number? How about we do 2 to the power of, wait, we have 8 bytes. 2 to the power of 7 times 42. That's gonna be a big number. So we're gonna need to do that a big int, maybe. So probably I should make this a big number such that works. We'll see. And then we're still missing the input text. This is the text. So cannot be applied to big int and number. What if both is a big int? And what if that is also a big int? Big int literals are not available when targeting lower than... What's my target? What did I set as my target? Didn't set any. There we go. Fixed it. Sometimes you just gotta fix them. So with that, we should now be able to call that program. Let's see. Can I call program? There we go. Success. Simulation was successful. We see that the system program created the account. Then we said we're writing. That's wrong. That's not good. Maybe the message is just wrong, but that's not good. What did I log here? Data account address. Oh, I was logging the address. That's what you get for calling it address. Obviously, at that point, the address was all zeros, so it's the system program. What I wanted to log was the key here. Oops, my bad. There you go. That's just a logging issue because we were logging this before we wrote it instead of logging the actual key. But just because, no, I don't have enough. I don't have enough salt to redeploy. Yeah, sucks. No, we're not gonna redeploy because I can't afford it. I can rebuild, I cannot redeploy. Ain't got enough salt for that. Yeah, there you go. Sucks. Okay, so not happening. Good. We're just gonna work with what we have. And then we got the transaction signature. Let's check it. The rest should have worked. We did create this account. So that is the account that was created. The TQA. Now, that account has 80 bytes. But that's about all that we see here. Oh no, look at that. There is anchor data. Ha! Isn't that nice? Because we were uploading the IDL, the Explorer knows what the structure of this account is, so it can tell us what the actual data is. And I already see that I made a mistake in my calculation, because that's not really the number that I wanted. But, you know, 5,376 is apparently what's in there. The Andy was correctly written. The text, wait, how can I make this so that you see it better? So here, now you see it better. The text was also correctly written and those bytes were also correctly written. But this I messed up. That's okay. So we do see the data here, but only because the IDL was published on chain. Often it's not so easy to get that info because either there is no IDL or you might not even know what the program is really doing or whatever. So maybe I want to manually get that information. But first I want to fix that. Hold on, I'm not happy with that. Why is that 5,000? I probably have an error in my... Where is it here? Probably have an error here in this calculation where I probably first want to do this and then this. Could that be? Can I log this? This, also that gives me 5,300. What am I doing wrong? Oh, I know what I'm doing wrong. Sorry, that's my bad because once again I was confusing bits and bytes. 2 to the power of 7 is of course the 7th bit, not the 7th byte. So what I wanted was 2 to the power of 7 times 8. That's what I wanted. Let's do that. Holy shit, that's a big number. It's just a very big number. Okay, wait, what? No, hold on, but they also get an error, I think. Code something. What the hell? Okay, hold on. This might be too big of a number. No, I'm not gonna ask the AI to give me the number that I was thinking of. I'm gonna figure this out myself. I need to train my brain to not always rely on AI, but also think sometimes. Otherwise, I get stupid. What am I messing up here? What I wanted, and that's just a side quest that I set for myself, is I wanted to set the highest byte to 42, such that in the end we get an array that looks like this: 1, 2, 3, 4, 5, 6, 7, 42, and take that as a number, an 8-byte number. So it should be 256 to the power of 7, right? But that's the same as I already had, or not? No, this looks better. There we go. We wrote that account, and the input number, yeah, that looks more like it. That's the input number that I put. And if we then check out that data account, the DB, I like it, DB wig. That's a great data account. I'm going to use that. If we check the data on the data account, it wrote that data there. Okay, wonderful. So that's better now. The Explorer helps us understand what's here. It is a data account of the beginner demo program. It can show me that because it has the IDL. Great. Another reason why you want to upload your IDL. It just makes debugging much easier. But what if you wouldn't have uploaded the IDL and you can't get that info from the Explorer? How can you do it manually? We are devs. We should be able to do this. Let's do a get data. And we're going to say the data account is the following address. This here. Import that from the kit. Okay. And now here we don't need a pair. We don't need any instructions or whatever. What we're going to do now is, again, from our generated code through Codama, there must be a fetch data account. There you go. And we can just use this fetch data account, give it the RPC and the data account address, and then it will fetch me a data account. So can get the data from this. There you go. And that data will then have all that interesting stuff. That's just the metadata. Every account stores that stuff. Well, it doesn't store what address is, but that's what it remembered here. That's just, again, giving me the address. Whether or not it's executable, that's metadata. The lamperts, every account has lamperts. Lamperts being the 10 to the minus 9 sol. So lamperts is just the smallest unit. It's like the Satoshis with Bitcoin. The program address, that's the owning program. So what program it is assigned to. That program can then change that account, the data of it, and can take the lamperts. And the space, that's also just metadata, how much data or how long is the data of that account. And the data itself, so I called it data, that's again not ideal. I'm gonna call this data account info, and then the account info will get me the data. And here, look at that. That will give me all the things that I stored myself, including the discriminator, which Anchor does. But Codama then just treats that as a U8 array or whatever you treat it as, U8 array. But I'm not too interested in that. I'm more interested in that address, the array, the number, and the text. Here I could directly access that, so I could log this, or I log the entire thing, then you will see it all. Let's do that. Let's get data. There you go. The discriminator, 8 bytes, not too fussed about that. But then we have the number, we have the address that is stored, we have that array, and we have the text. All of that information it got from the on-chain account at this address, the dbwig, and that's also what the Explorer is doing here. We were doing manually here. But we could only do that because we have that generated code that neatly parses that for us. Sometimes you want to understand what's happening without having such an IDL or the generated code. And in those cases, it is handy if you can look at the raw bytes. And I just love to do that. That's why I always do it in almost every video. And today, I'm gonna do it with you slowly, such that you can follow and really understand what it is that I'm doing. So, we established that this account, this here, the account with this address, has 80 bytes of data, and the data that is stored is this. But on Solana, the way you store data, it's always just bytes. It's just a sequence of bytes. And what you make of those bytes, like here we make of it a number and an address and an array and the text, that's your interpretation. So the program defines how the data is serialized and then deserialized. In our case, we defined it here by saying, hey, that's what the account looks like. But really, on chain, it's just a serialized piece of bytes. And serialized means one after the other. We put first the discriminator, then the number, then the address, then the array, then the text. That's what we do. We put it all just as bytes. And we can look at that by getting the data in a raw format. Like this is already getting the data and then deserializes it into those ready-made structs. If we wouldn't have the IDL, we could just get account info for that account. So that would be the raw info, raw account info. I could just get that. This will get me back the account info. If I get the value for that, this will also have the executable, Lampert's owner. Here it's called owner, not program address, but same, and space. So that's the metadata. And then the data itself, that's just base 58 encoded bytes. And if I don't want base 58, I can say encoding is base 64. Then I get base 64 encoded bytes. And to get the bytes out, I can get a base 64 codec and encode, so make the base 64 2 bytes. Again, that might still be confusing why it's called that, but that's what it's called. And that will give me the data bytes, and I can log them. So then I will get first the individual bytes is my RPC. Yeah, there we go. So we get 80 bytes. Those are the bytes. And you can already spot some patterns here. Here the first 8 bytes are, I'm not sure. But then there's a bunch of zeros. And then there's a 42. Oh, look, a 42. We know that from somewhere. And then there's a bunch of, looks like random stuff again. And then there's something that we recognize again. 1, 2, 3, 4, 5, 6, 7, 8. And then there's a 16 and 3 zeros. And then there's some other stuff that is almost random, but it's always in the same range. And then there's a 32 and then a 32 again and a 32 again. So we can spot patterns in here. And then there's a bunch of zeros at the end. When we look at that, we can make educated guesses what those things could be. And that is something that I do a lot of when I do development. I look on chain, hey, what's on that account? And I try to spot how stuff is stored. That's a large part of what I'm doing in my videos as well, just understanding the account layout, or what we call the state. But usually I do this when I don't have the IDL. Because we have the IDL, it's fairly simple to not just let that thing do. Why do I want to understand it? And why, as a dev, even if you have the IDL, why might you want to understand how it really is on chain? Well, maybe you want to work with an account from a different program and read it in your program. And in your program, getting the IDL in there might be a bit weird. So you just want to know what the correct offset is that you can read whatever, this array or whatever you might want to read, or this authority, that's the authority. Okay, but since we have the IDL, we can, from those bytes, get this. And I can also quickly prove that to you, because the fetch data account, what it does in the background, if you check that out, really is it decodes the data account. So it gets a data account decoder, and that stuff we can also get from here. Get data account codec, that's both the encoder and the decoder. So I can just do this. From the codec, I can then say decode. So now we get from the bytes to the data account. So we decode those data bytes. And then we should get something similar to what we get back here. So const decoded data is this, and the decoded data will also have the address, array, discriminator, and so on. And if I log the decoded data, it will give me the exact same as this. Just showcasing that. RPC is just a bit slow. We are doing 2 RPC calls here. First this one and then this one. This here is just manually doing this. So that's basically equivalent. There we go. So we see from those raw bytes, we get this, and then we do the basically same thing one more time in this fetch function. It's the same. because we have that decoder, we can decode those bytes that we get from account info, and the fetch basically puts that in a function such that you can directly call that if you just need that. Okay, good. That's the Codama way of doing things with those encoders, decoders. But sometimes we don't have the IDL. Sometimes we can just look at the bytes. And then looking at this is a bit not so pleasant. I do it differently. Now, usually when I want to look at an account, I don't write myself a script that what I do is I use the CLI. I would do something like Solana account, give me that account. So I'm using the Solana CLI to decode that account. And what it gives me is the metadata that we also saw here, for instance. That stuff, the address, that's the pubkey, still wrong. In this case, it is a pubkey, but it doesn't need to be. The balance, so that's the Lamperts. The owner, that's the program address. Which program owns that account? That's my demo program that can write to this account. Whether or not it's executable, the rand epoch, and the length, 80 bytes. Okay, and then, and that's the most interesting thing to me, it gives me the actual bytes as data. So that is now the same thing as we had up here, those 80 bytes formatted a bit differently. This is more or less a hex dump of the account. What does that mean? We don't show the bytes as values from 0 to 255. 1 byte can have 256 states. So it's in decimal, it would be 0 to 255, but we show it in hex. Why hex? Because hex with its base 16 has a convenient power of 2 such that every byte has exactly 2 characters. Because in decimal some have 2, some have 3, and we waste a lot of space. If we do it in hex, it just looks nicer. And it's just easier with this alignment because here I don't know, like sometimes I have 4 in a line, sometimes I have 12. That makes no sense. That's just all a bit weird. It's just a bunch of, I mean, I can read it, but it's easier this way because here I know the way that is printed as well with the 2 spaces here, that's 4 bytes. Then we have 2 spaces. That's 8 bytes. Then we have 2 again. And then the whole line is 16 bytes. In hex, 1, 0. So byte number 17 comes here, and then byte 32. So those are then 32 bytes, 20 in hex. And so that would then be 64 bytes. And that way it's easier to just work and count if it has this nice alignment. That's why I like this hex dump. We can already neatly see here then, if that's 4 bytes, that's another 4 byte, that's 8 bytes. And we know that in the beginning, there is the discriminator. So those 8 bytes of the discriminator, you can tell by the 7 here, for instance, the 0, 7 is the same. This 7 goes here. Also the 1, 2 is 18, 16 plus 2. That's decimal, that's hex. And so the E9 must be the 223. So that's the discriminator. Then comes our number, and we know that this has 8 bytes. So again, 8 bytes to 2A, which is 42 in hex. So in this number, we just set the highest byte to 42. So this is 42 times 256 to the power of 7. In decimal, that huge number is here. And it's us who interpret it that way. We say, oh, those 8 bytes, if we interpret it as a number, then it's that number. But it could be an array as well, right? We could have an array with 7 zeros and then the byte 42. If we interpret it as an array, fair enough, same thing. Like on-chain, it doesn't make a difference. On-chain doesn't store the data type. On-chain just stores the serialized data. That's why we'll have to do a lot of guessing here. We would need to do a lot of guessing here as well. We don't know, that looks like random bytes, but we know that there is an address, and because that looks like something specific, here it looks like something specific. So those conveniently 32 bytes, we know it's 32 because it's 2 lines downwards, so twice 16. Those 32 bytes are likely to be an address. And indeed, it is that address. If I would convert that to hex bytes, we would get this. And we've done it in previous videos and not gonna do that exercise now, but feel free to do so. So that 32 bytes is the address, and then comes the 8 bytes of our array. And it's just an array because we said it is an array. I could interpret that as a U64 number. Nobody's gonna stop me if I do that. And then I get some result, some big number. It's up to the devs what they make of the data. So that's why the deserialization and serialization is such an important thing in Solana development, which is also the reason why I enjoy or want to work with or look at it in the hex dump. Because I want to really understand how it is serialized and what's actually on chain. That's why I keep looking at that. And that might be confusing to some people. That's why I'm going over it quite slowly today. So that's that. What do we have next? Another nice little 4-byte block here that starts with 1 0 and then 3 zeros. So if we interpret that as a number, as a 4-byte number, you know, a U32, then that would be 1 0 in hex, so 16. That would be 16. And if we interpret the number again as it means the length for what comes next, and what comes next is a string, then we can say, okay, the next 16 characters belong to a string. So starting here, those 4, those 4, those 4, and those 4, that's our string. So one full line here, that's 16 bytes making up our string. And sometimes it's really helpful to interpret that stuff as ASCII or UTF-8, but really here it's just ASCII because for regular letters it's the same. And that's where that thing comes in. This here displays all the bytes as ASCII characters, if they are nice characters. Otherwise, you'll get a dot instead. This is not the real ASCII representation of the exact bytes, but only if they're nicely printable, then you get the ASCII characters. Otherwise, you get the dots. So here, none of that is really, you know, nice ASCII. There's, you know, it kind of looks random because it is, except for the 2A, which is the 42. That's a character that is printable. But anyway, it gets interesting here. Those 16 bytes here, this is the text. That's what it looks like in ASCII. So if we have some ASCII stuff stored in the data, then we can see it here in this part on the very right. This indicates the length. This indicates the actual data in hex. And this is the data in ASCII. That's why I like this kind of a hex dump, because it shows me all of that. And in case that wasn't clear, you know, this corresponds to this. This corresponds to this. So those 4 bytes correspond to those 4 bytes or letters. This literally corresponds to this. Yeah? Makes sense? So those 16 bytes, these here, that's the text. And then we have 4 more bytes, 4 zeros for padding. We're not really using them. That's additional zeros in the account that don't represent anything. Why do we have them here? Well, because when we created the account, we said our string length is maximum 20 and our real string length was just 16. So we allocated another additional 4 bytes just in case the string might be longer. That's the reason. And I think with that I'm done. I explained the thing that I wanted to explain, how this works and what I'm doing if I'm looking at those hex numbers here. I hope that you understand that now. It's basically the manual way of getting those things, where the address, we find it here, the discriminator is here, the number is here, the text is here, and so on. I'm gonna end with a question and then some homework. Because we have this max string length, what would happen if I create an account with a string longer than 20? So if I call the program and I give text, this is text longer than 20 characters, what do you think is gonna happen? Make a quick guess. I'm gonna show you the program again. This is what we're doing. It's an anchor program. We just write the input into here. The input, of course, will be longer. We didn't specify a boundary for that. So that will still have the entire string, but then when we set it here, what's gonna happen? What happens if we set that text longer than the allowed 20 characters? If you wanna still think about it, pause the video. Here comes the solution. We never check that this string can only have that length. So we just write it here as well with a different length. However, what's gonna happen then is that we're gonna run out of account space, which is no problem for our instruction because it will still write it there. But if we don't change the space and then also put more rent on the account, if we don't reallocate the account, then it will be lost. The additional bytes will be lost because after the instruction or after the transaction, really, the account will be shrunk down to those 80 bytes that we specified here. And then we will just say text lon. The remaining info will get dropped. That's what I expect that happens. Let's demo, and I'm gonna log the data account since my program is not doing that correctly. So we run the program. Nope, not Codama. We call the program. That's gonna be my account. Oof, no, maybe I was wrong. Account did not serialize. Oh great, failed to serialize account. That's what we're getting. Cool, I was wrong. And that's another thing that I like to do, being wrong. Because then I learn. I would have expected that Anchor just writes the text here and then, you know, whatever. If we were to do that with Pinocchio or whatever, then that would be the result that we get. But the way Anchor serializes is it actually does proper serialization, which is good. Anchor is doing more checks than I expected that it does. So that's good for beginner devs especially. Because then you see that you made a mistake and you can't really store that. Cool. If that was your solution, great. You're smarter than me. You're a better Anchor dev than I am. And that's cool. Like, being wrong is part of the game. I love being wrong because then I learn. So yeah, I had a wrong assumption. We failed in the serialization. So we cannot put what we wrote here onto this account because it doesn't have enough space. And then Anchor fails. Cool, good to know. So that answers my question that I answered the wrong way. Now for the homework, let's go back to shorter text. For your homework, you can try to do this without having the IDL, without having the generated code. Because then it's the same thing, just the other way. You will need to create that data manually. And that's also something that I enjoy doing because that way I can call any program even if I don't have the IDL, if I just build the instruction data correctly. So without calling this, doing the same thing. How do you do it? That's homework. And I'm gonna give you the solution for the homework after I'm done with the conclusion of this video. So, I can finally wear this thing again. Nice and green, huh? Nice, nice, nice. So, thanks for watching this video. I hope it was helpful. I hope that I could now get you up to speed on the things that I'm doing when doing Solana development. I hope you understand how the hex dumping of the data of accounts works and just take you along on the journey how I go about writing an Anchor program and using Codama, the Solana kit. So those are all things that I keep using in almost all of my videos. You will come across that. So it's good that we had a look at that together in a bit slower pace. If you still have questions and I still did things that you're like, I don't know what he's doing here. Maybe I still have some automatisms that I don't explain and I always do the same and you just don't get it. So feel free to ask in the comments or tag me on Twitter and say, hey, can you go through this more slowly again? I'll gladly help, because I want as many of you to be able to follow along in my videos when we actually look at more interesting things and do more advanced Solana development. And all of what we did today is just part of it. We need to know our basics to play with the cool things. So today wasn't more of a basics video. Let me know what else I should make videos about. And otherwise, here's some that are already made. Give this one a like if you enjoyed it, subscribe if you haven't done that, share it with some other Solana devs who might want to enjoy my videos, and then I will see you in an upcoming one. And now, the solution for the homework. Oh wait, I can't put the videos here. The videos will show up in a second. You can also just click away. Do the homework first, try it first before you watch me do it, but just for completeness, let's do that together. for you to check if you did it right. The solution to your homework. I'm going undercover for doing the homework for you. We want to do this, but we don't have access to that generated code. So what do? We create an instruction manually. What program do we call? We can hard code that address to our program. We can just copy that from here. Then what else do we need? The accounts. So accounts is an array of 3 accounts. First account is the payer. So we give the payer address, role, account role, writable signer. Then comes the data account. So I give the data account address as writable. And then comes the system program. This one will be read only, and it will be the address of the system program, which I'm going to hard code because I can't be bothered to import the Solana program system package. There you go. That's the accounts. And then we're just missing the data. That's the more difficult thing if we don't have the encoders for it. So what did we say? I'm just going to do a uint8 array, and I'm just going to hard code stuff like this. So the first 8 bytes are going to be the discriminator. If I don't know what that is, it can be very helpful to look at a transaction and look at what it has done before. Look at it like this and then be like, oh, I want to do something like that again. So that in hex is the discriminator, the AF. If you want to know where that comes from, just as a reminder, or if you've never done that before, it's a SHA-256 of global, then the instruction name, which was initialize. If we run that, there we go. Then we get AF, shalalala, and the first 8 bytes it takes as the discriminator. So I just need to take 8 bytes of that, and I'm gonna create an array from that. And then I have those bytes. So that thing, gonna borrow that to the call program. I'm gonna call it discriminator. Those 8 bytes will be my discriminator. And then I want to have a number. I don't know, let's just store the same thing. Why not? I want to have the text, just so we do the same thing. And then from that I can do the instruction data. So the instruction data is just gonna be another uint8 array that first has the discriminator. So I'm gonna put the discriminator. Then I need to put the number as a uint8 array. So I'm gonna get a U64 encoder to encode this number and then flatten this into this array. And then I'm gonna do the same thing with a text with a get string. Oh, what's the codec for that? A UTF-8 encoder, there we go, of the text. But this alone will not suffice. That won't be it, because that's just the 16 bytes of the text. We still need the 4 bytes for the length. So I know that the length of the text is less than 256. So I'm just gonna say length and then 3 zeros. That's my manual way of encoding the length here. I just need to get it to work. It doesn't need to be pretty or perfect or whatever. And that way, with all of this, I think we're done for instruction data. We just put the instruction data here now, and that should be the same as this then. Let's try. Well, actually, let's say this is new text. So shall we change something? Let's call the program with this. That's the account. Oh, we still made a mistake. Cross-program invocation with unauthorized signer or writable account, because I said writable, but this is supposed to be a writable signer. That is true. Why is it a writable signer? Because we need to sign for this such that the system program can create the account. Solana basics. I mean, we have it as a signer. We just need to also provide it as a signer. Okay, my bad. Let's do that again. That is still wrong. I didn't save it. Let's try that again. There we go. Ugh. Transaction signature. Ah, yeah. Okay. So now we said this is going to be a signer, but I'm not actually signing for it. So that's an issue down here. I'm just signing with this one. Actually, I should do that here, no? So here I would need to say add signers to instruction, provide data account as a signer, and then the instruction. Here expect signers. There you go. So an array, just this signer, add that as a signer to this instruction. Because we're building it manually, this instruction, I need to manually add that signer. Fine. But now, there we go. Now it worked. And this is the account. And if I say Solana account for this, then we will see this is the new text and the rest is the same. Nice. Homework completed. You're welcome. But obviously, this here is so much easier than doing all of that stuff and that stuff, you know? That's just how we manually do it if we can't do that because we don't have that generated code. And sometimes it's also just good to do it manually with this because then you learn. Then you need to think about, do I need to provide this as a signer, writable signer, just writable? I like to do that stuff manually sometimes just so I really understand what's going on. Because if I just do this, then it works, but I don't really understand what's going on. Or I might not understand what's going on and have wrong assumptions. So that's why I like doing those things, and that's why it's good that I walked you through it. Okay, and with that, I shall leave you. Now you can have the videos to watch. If you haven't yet, give it a like, do subscribe, and I'll see you in the next one.